Hi everyone, in today's lesson we're going to talk about increasing and decreasing functions as well as maximums and minimums. So in pre-calculus we were taught the following things. Given a graph, we were able to find where the graph is increasing, where the graph is decreasing, what is the relative max, and what is the relative min. So just to recall, increasing and decreasing is like you kind of want to pretend you're on a roller coaster. So if you were here and you were going down, would you agree you're decreasing? Okay, then we're going to go from here to here, we're going to go up, and then from here to here, we're going to go down. But what we have to remember is that when we are finding intervals of increasing and decreasing, it's the x values. So if you think about it, we can kind of say, well, from all the x values from here to here, my graph is going down. So the x value at the smallest is negative infinity, and the value at the last point is 0. So we'll say the graph is decreasing from negative infinity to 0. And it's actually also decreasing from this point over. So from here to here, it's going down. That x value is 2, and it ends at an x value of infinity. So there are actually 2 spots where this thing is decreasing. And then the only spot left is increasing. So it's actually increasing from about here to here. So those x values are here, down here, from 0 to 2. So that is where the graph is increasing. And our relative max would be where the graph has a maximum, so which it looks like here. So we could label that as our maximum, and then we can label this one as our minimum. And we're just going to put the relative maximum as a point, which I see here is 2, 2. And the relative min is the point 0, negative 2. So these values are relatively easy to find if we have a picture, right? Now, how do we make connections to this, though, to calculus? So if we go down here, let's try to make the connection. So if I have the slope of a tangent line is 0, what does that imply? Well, what I'm looking for you to see here is that you see that this spot right here has a horizontal tangent. So our f prime, our derivative, is going to be equal to 0. What does that imply? Well, here our derivative is also 0. That implies when our derivative is 0 that we're going to have a maximum value or a minimum value. Okay? Now, the slope of the curve. Alright, so this curve, this slope, would you agree is a negative slope? This slope is also a negative slope. And those are the spots where the graph was decreasing. Okay, so if we have a negative slope, that's where the graph is decreasing. And where the slope is positive, so you see going up, that's a positive slope, then the graph is increasing. All right, so that is the calculus connection. Okay, so now let's just say we did not have this picture right here. How could we find all of this information? And we actually can use calculus for that. So let's go to the back. Alright, so the first thing that we always want to do is find the derivative, okay? So step 1, find the derivative. So f prime is equal to negative 3x squared plus 6x. Now, like we said before, if we take the derivative and set it equal to 0, we'll have our horizontal tangents. And those horizontal tangents have a maximum or a minimum value. Okay, so here when we factor, we're going to take out a GCF of negative 3x, and we're left with x minus 2. And we're going to set each piece equal to 0 and solve. So what you just found are called critical values. So these two are critical values. At critical values, we will have a maximum or minimum. Now, up until this point, I haven't taught you which one is which. So the way that we figure this out is kind of the same way that we did that velocity timeline with the motion of a line. So what you're going to do is you're going to, on a number line, you're going to use your v of t function, your velocity function, which is the same thing as your f prime, right? Your derivative function. And you're going to put those two critical values. We have 0 and we have 2. And we're going to do some test points. But we're testing into the f prime function, this function right here, not the original. And we're going to test some values. So let's see if we could test a value to the left of 0. Let's just call it, I don't know, -1. And then we're going to test a value in between. So we'll say that's +1. And a number after, which we'll say is 3. So again, we're putting it into the f prime function. So f prime of -1, f prime of 1, and f prime of 3. All right, so what I'd actually like you to do is take a minute and pause the video and plug these 3 values into your derivative function and find out what they equal. And then hit resume when you're ready. Okay, these should be your answers. So what we found was that when x is -1, y was -9. So what that means is that this area here is negative. And when x was 1, y was 3, which is positive. So we found that this area is positive. And then the same thing, when f was 3, we had another -9. So that means this area is negative. So to figure out which one of these values, 0 or 2, to figure out which one is a max or a min, you have to think about, well, what's happening at the graph? So because we have this minus here, that means the graph is going down this way. So we could draw like a little bit of a sketch. It's going down, 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 down. But then once it hits 0, it starts going up, right? And then once it hits 2, it starts going down. So you can clearly see that this one is your minimum and this one is your maximum. We actually have the x value is 0 is actually my maximum. Oh, excuse me, my minimum. And my x value of 2 is actually my maximum. Now, how do you find those coordinates? We just plug into the original function. So where it says step 4, find the relative max and min by comparing the signs, right? We're going to plug x values, so you might want to even write this. Plug x values into f of x, the original function, not f prime. So we can go ahead and do that. Okay, so f of our maximum is at x equals 2. So we want to do f of 2. So negative and then 2 to the third plus 3 times 2 squared minus 2. And our minimum is at x equals 0. So we want to do f of 0. So I'm plugging into the original function. So take a minute, pause the video, and see if you can get the 2 answers, and then hit resume when you're ready. Okay, these are your answers. So the first one is your maximum, if you want to label that. And the second one down here is your minimum. Okay, so just to recap, what we did was we took the derivative and we set the derivative equal to 0. And we found our 2 critical values. Now these critical values could either be a maximum or a minimum. So what we did was we made a number line with the velocity. I know I call it velocity, but I mean the first derivative function. And I put these 2 critical values here. And then I did test points, and I test into the derivative function. I'm testing numbers in between, and I'm seeing if they're positive or negative. If it's negative, the graph is going down. If it's positive, the graph is going up. And then if it's negative, it's going back down. So we can clearly see that the minimum is at 0 and the maximum is at 2. So all I had to do was plug in those x values into the original function to find the actual max and min values. And then the last thing that we probably should do is I also want to find the intervals of where it's increasing and decreasing. So the interval of increase is just where it's positive. So it's positive from 0 to 2. And where the graph is decreasing, it's just where the sign is negative. So from here to here and from here to here. So if it's starting this, you could just say negative infinity to 0. So negative infinity to 0. And then from 2 to positive infinity would be enough. All right. So the first derivative can help us find a lot of things about the original function. It could tell us where it's increasing and decreasing, and it could tell us the values of the maximums and the minimums. All right. If you have any questions, please let me know tomorrow. Have a good day.